Right, figure 4. Figure 4 of Pssd N2. So let's look at figure 4, Pssd N2 of this previous question paper. This one, 20 April 2021. So figure 4. So this is the question of figure 4. These are the question of figure 4. Diagram sheet 3 attached shows a part of a rectangular tank fitted with an oblique pipe at an angle of 60 degrees to the horizontal. Draw the given view to marks. Draw the development of the pattern of the oblique pipe, 12 marks. Draw the true shape of the hole as seen in the direction TT. As seen in the direction TT, 6 marks, which is this one. The direction of the hole, which is going to be this one. Direction of the hole. Alright, so then let's see. Let's start. We are using what? Scale of what? Scale of 1:2. It's a reduction scale, 1:2. Reduction scale. So let's start. So I'll decide to start here, just right next to this one that we just finished now. So I'll have a faint line going like this, and a vertical one coming down like this. Right, then from this point I'll start to draw this line from here till there, out of dimension. It's this one, isn't it? So from here going down, I can record this dimension of what? Of 196. 196 divided by 2. Have your calculator. 196 divided by 2. I am getting 98 millimeter. So 98. This is 100. This is 90. 99, 98 is ending right here. Where my 98 ends, I can put a solid line, which is this one. So this side I can have this line, shows what it has still continuing. You understand? Then from there, this one I can have it solid dark. From here, going up, which is this one. Then from there, what are we going to have now? From here going down, diameter. I think I was supposed to draw it down just a little bit. Okay, but I'll see that 104 divided by 2. So divided by 2, 52 millimeter. So 52, 51, 52. See this one. So this 52, that's when we're going to put angle 60 degrees anti-clockwise direction, like this. This one, where our 104 millimeter divided by 2 is ending, I am going to put angle 60. There you go. Till where? Till here. Because if you check this one, they are at a same line. They are together in the same line. This one, you understand? If you put, you see, they're in the same line. So which means same applies to this one of mine. Once it gets here, it can go up now. It can go up vertical up. Gonna go up up. So unfortunately I've limited myself too much. I was supposed to draw it a little bit down, but now let's see what is going to happen. Then from here till here, 20 divided by 2, we are having 10 millimeter. So which is this one. There is my 10 ending, isn't it? So because they said reduction scale. Reduction scale. Then where my 10 ends, I can put a vertical line. Neat. Let me start here. Alright guys, so now we are going to draw diameter 72, which is this one. Diameter 72 way right here. So we are going to say 72, not 73, 72 divided by 2, we are getting 36. So now I can open my drawing compass to 36, 35, 36. Let me remind myself what was the scale. This is figure 4. Figure 4. Okay, yes, the scale is 1:2. Scale 1:2. So I'm getting 36, which means I'm still going to say 36 divided by 2, getting 18. So I'm going to open it to 18 millimeter. This is 19, 18. This is this one. 18 is this one, right? Then from there, 18, just be accurate. This is 18 millimeter. Then I can draw the 18 up there. Millimeter up there. So it's going out of the page. Let me do it nicely. So where I was placing my drawing compass, let me put the center, horizontal center line. So it was actually here. So now I can project this circumference down so that I get this one. From here till here, from here till here, as well as that one. So now I can simply project this point down as well as that one down. So from here till here is 18 millimeter. So I can have it dark now. There you go. From here till there. Again, we are told that is dark even here from here till here, isn't it? So I can have it dark from here till there. Then from there, so there you go, and there you go. So which is this one? From here till here is this one. From here till here is this one. Remember the reduction scale, it's 1:2. We are using 1:2. So the hatches, so which means from here till here is 10 millimeter. So the angle, the scale does not divide the angle. You also remember, so angle we are not going to divide it. So now angle 60, it will be angle 60. So from here till here now, solid, dark already. Then again from here till down here, solid. So which that I have now till there, isn't it? So now told ukuthi the XX is here, X, and you must know ukuthi that XX is the joint, and the TT is actually where the TT, which is the shape of the hole, is actually from here till here. So the TT which they are talking about, this one, from here till there. So right, so if now let's start to develop the what, this one, because they said angle 4, so what, figure 4. So it's figure 4 attached, shows the part of a rectangular tank fitted with an oblique pipe at an angle of 60. Isn't it? Remember we've read the question of this one. So now we are being asked to express the full development. Right, the full development. So we are going to project lines that would be parallel, perpendicular against our what? Our cutting plane. So perpendicular against it. So which means if we draw these lines at an angle of 60 anti-clockwise like this, so if we want to obtain a line that is perpendicular against that, we are going to use angle 30. So we'll take this one, faint this direction, and take this one, faint this direction. This what? The XX, which is our cutting plane. Then from there we go back up there. We have to divide the circle into 12 equal parts. This one, we have to divide it into the 12 equal parts. So you remember how do you divide a circle into 12 equal parts? We've got two methods, whether you use a protractor or you use your ruler, set square, this one. So I can simply use this one. So there we go, even though it's going out of the page. So again from here, there you go. Then this side, there we go. This other side, so there we go. So I can decide to make this one 0, this 11, this 10, this one 9, this one 8, this one 7, this one 6. So the 5, 4, 3, 2, 1, back to 0, they are up there. So now I'm going to project them down. So the 11, we assume the one is up there, they're going to be in line. So I'm going to further extend it up until it touches this point. That's when I'm going to stop. So the point 10, it will be in line with what? With 2. Once I touch there, I stop. So point 3 in line with 9, which is our center. Then point 8 is going to be in line with 4. Point 5 in line with 7. Right, once they touch there, so we are going to take them at an angle of 60 as well, like this. There it goes, faint now. There it goes. There it goes. So there it goes. Then from there, what are we going to do? So we are going to have this one Now we are going to take them at an angle of 30 clockwise direction. This point, this one, yeah, can you open? So let me take it. So there it goes, faint. There it goes. Then the center, I'm going to take it as a center. There it goes. So and there you go. 0.5 and 0.6. Right, we took them near. Once they touch the main pipe, so you take them at an angle of 30 degrees clockwise direction. So even up there, this one is your 0, isn't it? So you have to take it as well. So 1 and 11, this one, there you go. Extend it. There you go. 10 and 2, 3 and 9, center. So 4 and 8, 7 and 5, 6 on its own. So from here, so now I can have my development to the side. So guys, I hope you can see my faint lines. So I can have my development this side now. So now from away from my pipe, so I must measure a dimension, any dimension, but that is above 20. So which means I cannot separate it with any dimension less than 20. You understand? So it's good as if I can say 20 millimeter or 25 or 30 due to you, as much as you have enough space. You understand? So as long as it's not 15 or 10 towards your pipe or your main pipe. So from here I can have this line at an angle of 60 anti-clockwise. So from here then I can use this formula of L is equals to pi diameter over 12. You know this formula, isn't it? So where you substitute your D with what? With the D of that pipe you are developing. You understand? Or graphically, you can easily come and just take this, because this space they must be equally. Understand? So from 9 to 8, or from 8 to 7, or 7 to 6, it should be still the same thing. Then from there I can now come here at my development and mark. From here I mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. So once you get here, so you can take them at this angle 60 anti-clockwise faint. There you go, all of them. There you go, there you go, this one, there you go, 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 and the last one. So then, you've got some points that you have to rely on. You have to have some points that you are going to rely on, such as which one? Such as this one. So from here till here supposed to be dark, which is what? Which is your XX. So this XX is the one that is supposed to be dark from here till here, even at the end. That one you must know, because in some cases you'll develop problems that you have never seen them. So seen them before, so you must have some points to rely on. So from here till here, if it's XX, so which XX I must get it. Can you use your it's disturbing me, distracting me actually. And then so let's go, sorry about that. So I'm going to say this is X0, 1 2 3 4 5 6 7 8 9 10 11, back to 0. So what we know is that the point 0 must intersect with a 0, point 1 must intersect with 1, 2 with a 2. So check, come back to your auxiliary. We decide to put our 0 there. So there it goes. Once it touch here, it goes to what? To your development. So which means it's gonna intersect with what? With a 0 there. I've got a 0 here. And like as I've said, which means from X to X, without fear or favor, I must have a solid line, which is this one. This one, which is, I can simply say this is the X, this one is this one, this one is right here. You understand? So even at the end, I am going to have this very same thing. At 0, which is from here till here, I can have it from here till right here, which is the X. So if you've got such point to rely on, you can easily tell how is your development going to look like. You understand? And starting at 0 to 6, which means point 6 must be the last point. So let's get these points then, let's trace them. So 0, right from your auxiliary, isn't it? We trace it there, it goes. Once it touch here, goes to your development. It's going to intersect with this 0. So point 2, which is in line with 11, there it goes. It's the second one. There it goes. Oh, point 1, not 2. Remember 0, 1. So point 1 in line with 11, there it goes, there it goes. It's going to give me a point intersecting with what? With point 1. So point 2 in line with what? With 10. A1. So there it goes. Once it touch there, let me do it like this. I think it's clear now. So there it goes, giving me a point there. So you mustn't just claim ukuthi they go diagonal. You must know how are they going like that. So point 3 in line with 9, which is the center. There it goes, there it goes. This is 3. So it's going to give me a point right there. So point 4 in line with what? With 8, above the center. From there, it goes 4 in line with 8. Point 5 in line with 7. That goes from there. So which means I've got a point there. Point 6, which is this one, isn't it? From there, that goes. From there, there it is. So point 6, which is the last point. So point 7, which is this one, which we can see it now. This is it. There it goes. 7. This is 7. There it is. So where they're colliding, I've got a point there. 8 is this one. There it goes. Want to touch there, intersecting with what? With point 8. There it is. 9, which you can see from there. There it goes. There it goes. Which means I'm having a point right here. 10, there it is. Trace it. There it is. 11, there you go, there you go, there you go. Intersecting with what? With 11. 12, which is the same point with what? With 0. There it goes, which is this one. Understand? So now we can what? We can get our development. I mean, we can use a freehand or your flexi curve to join the point. But at this point, they must be plotted like this. Before, they must be well plotted. So that's how you get a development in this bottom part. So this upper part, what you did here, you'll be doing it here now. So a 0 is still the same 0, 1 is still the same 1, 2, 3, 4, 5, 6. You understand? So of which is what now you'll be doing it up there. So you trace it. It start here, 0. From there it goes from here. Once it touch here, you go, which means it must intersect with what? With a 0. So I've got a point here. Point 1 is this one. So 1 in line with 11. There it goes. Once it touch here, I'm now coming up like this, isn't it? Once it gets here, there it is. So once they intersect, it's my point. So point 2 in line with 10. There it is. From there it goes. From here, there it comes, then it comes, which means I've got a point here. Everyone. Then point 3, which is the center in line with what? With 9. From your auxiliary, once it gets there, the center, there it goes, which means I've got a point here. Then point 4 in line with 8, there it goes from here. Here it comes from here. There you go, intersecting with what? With this one. So which means I've got a what? A point here. Point 5 right there. Point 6, which is the last one. Yeah. So 6, 7 in line with 5. This is the line of 5. There you go. 8 in line with 4. We are descending now. Then 9 in line with 3. 10 in line with 2. 1 in line with 11. 12 in line with 0. In line with 0 like this. So now we can have our development using your flexi curve or freehand. You can get your development like this. There you go. So that's how you get the development of this one. So now let's see the shape of the home.